Hey everybody. Okay, so we just finished me showing you how to do it on the calculator. Okay, and so you can do it by hand. You're welcome to. I'm going to show you like how to do this one on the calculator. So let's read it and write everything. Excuse me. So you select 20 cars of the same model. That's your sample size. And were sold at a car dealership, and you want to determine how many days that car sat on the lot. So the sample mean is 9.75 days with a sample standard deviation of 2.39. Sample standard deviation tells us we're going to use the T. We want a 99% confidence interval for the population mean number of days that the car sits on the dealership slot. Assume it's normally distributed. So this is less than 30, right? And if it didn't say this piece right here, we couldn't do the problem at all. It has to, if it's less than 30, it has to have that. All right, so we're going to go to stat, which we're in statistics, go over to test, and we're going to go to the T interval. Okay. Then I'm going to type what I need to type in. All right, so that X bar, 9.75, that's our mean. X, that's the sample standard deviation, that's 2.39. N is how many there are, 20. And then our confidence level, our C level is 0.99. Make sure you change it to a decimal. All right, so it's between 8.22 days and 11.2 days. All right, notice it goes to the hundredths. Yeah, it goes to the hundredths. So we need to go to the thousands because that's the rule for rounding. All right, so 8.221 U 11.279. All right, we can write it as an interval. This means I'm 99% confident that the car is going to sit on the lot between 8.221 days and 11.279 days. Okay, or we can write it as a margin of error. And so if we're using the calculator, we can use the formula for margin of error. If we're using the calculator, all we need to do is take this guy and then subtract each of those, and that will give us the margin of error. So we're going to do 9.75 plus or minus, and I'm going to do 9.75 minus 8.221, 9 minus 11.279. Oh, 9.75. I did the wrong thing. Minus 8.221. 9.75 minus 11.279. We get the exact same number, 1.529. All right, so the margin of error is a day and a half. Okay, so just make sure that you can get both ways. All right, here we are. A random sample of 10 children, okay, so that's how many there are, found that their average growth of the first year was 9.8 increase. Assume the variable is normal. All right, it's less than 30, so they have to tell us that. The sample standard deviation, that's how we know it's T, is 0.96. Find the 95% confidence interval. All right, 95%. So I'm going to go to stat because we're in statistics, go over to test, go down to T interval. All right, and I'm going to type in 9.8 for X bar. S is 0.96. There's 10 kids, and it's 0.95. All right, so it's 9.1 and 10.5. Okay, this is 100, so I need to go one less. So it'll be 9.113 mu 10.487. All right, and that's if I want it as an interval. Now, if I want it as a margin of error, And I'm going to take that 9.8 and then subtract each of it. So let me do that real quick. Oops, 9.8 minus 9.113, 9.8 minus 10.487, and I get 0.687. Alright, so that's my margin of error, this 0.687. Okay, and so this means I'm 95% confident that children will grow in their first year between 9.113 inches and 10.487 inches. Or I could say I'm 95% confident that the children will be 9.8 inches, give or take 0.6787 inches. All right, now let's do one where we have to put data in. Okay, so the data below represents number of home fires started by candles in the past several years. Find 90% confidence. All right, so when we have a list of data, go put it in a list. So you push stat, edit, okay, and I'm going to go put it in a list. I'm putting mine in list 2. You have something in list 1. I don't know. You can put it in whatever list you want. Oops, 9930. All right, there are 7 things. All right, and so notice that on the last thing it says L, and then in parentheses it says 7. So I know, like, I've at least gotten to the right spot. Maybe I, typed something wrong. I don't think I did, but it's always a possibility. All right, so it's in my list. I'm still going to go to stat, test, and then T interval. Okay, so we have data this time, okay, and it's located in a list. Okay, and so let me blow this up. Let's see. My beautiful self. I really just want you to see the calculator. All right, my data happens to be in list 2. Okay, yours might be in list 1. And then you put your confidence interval. I think it was 90%. And so it'll be between 5858 and 8224, wide range. But then after it does that, it tells you like the mean sample standard deviation of how many there were. Yeah, 90%. Okay, so it's 5. These are all whole numbers, so I just need to go to the tens. 5858.8 mu 8224.1. All right, so that's as an interval. If I need it as like a margin of error, then it told me 70.4, give or take. It told me the mean. And then to get this margin of error, remember, I just take this guy and subtract, and then this guy and that subtract. 70. I hope you're doing this with me. 7041.1 minus 5858.1. 7041.4 minus 8224.1. All right, I get 1. Oh, hang on, I want to double check something. I typed it in wrong. 4. Wait a minute. Okay, let's try this again. 7041.4 minus 5858.1. 7041.4 minus 8224.1. Hang on, guys. I want to double check, make sure I typed everything in right because I'm not getting the same answer. 0.9, 0.92. I typed something in wrong. 704. Oh, okay. Here's the deal. All right, look. The X bar 7041.4. I'm rounding that. okay? And so I didn't round the interval. I just wrote it exactly as is. And so when I rounded, the thing, this says an 8. I might be a little off. So we just need to keep that in mind. Don't stress about it. I'm a very fair grader. All right, 8224.1 minus 70. All right, so when I do this, look, I get two different numbers. Just, if this was multiple choice, okay, I wouldn't give you both of those. I'd give you one of them and you just pick it because there's a rounding issue. But I most likely would just ask you to, do that piece. Don't stress. Let's just put, okay, I'll put both. And then you can look if it's a multiple choice. All right, so summary. T-distribution, you know the sample standard deviation. You don't know population. If it says population, use the Z. It's greater than 30, or if it's less than 30, it tells you that it's normally distributed. Just another fact, it's not going to really, you're not going to really come in contact necessarily with it, but it's got to be more than 5% of the population. All right, we use the t-table, and so in order to look up the number on the t-table, you need to know the degrees of freedom and the confidence interval. The three main ones we're going to use in this course are 90, 95, 99. All right, so here's the formulas. Should say X. But you could also just use the t-interval, and then depending on if you had data in a list, or if you just straight up, it tells you the information, you can type it in and push push calculate rather. All right, so this is when we don't know the population standard deviation, we know the sample standard deviation, and how we can find an interval to estimate the population parameter, the information in the population. All right, so in the next video, we're going to start if it's less than 5% of the population, and you don't necessarily have to calculate it. It'll give you clues. Like this clue for this type of problem is if you see the word sample standard deviation, and the clue for the Z is if it says population standard deviation. And so there'll be another clue on when we use the other kind of confidence interval. All right, I'll talk to y'all soon. Bye.